So for the next piece of our agenda, we wanted just to real briefly cover, kind of building off of Bridget's presentation, what does our emissions inventory look like and ground you in that data. So I'm going to move through this relatively quickly, given how much time we have available. And just in terms of a little climate action history, so as you heard from Bridget, we signed the Second Nature Carbon Commitment in 2008. And then we published our first plan in 2011. And that plan identified the strategies that we were going to undertake in order to reduce our greenhouse gas emissions from campus, with a goal of trying to hit approximately a 50% reduction by 2021. And that's compared to that 2008 baseline data. And then the plan also briefly addresses how we were going to integrate climate change into teaching and research. And so that's really kind of the context behind the plan that has guided our efforts over the last 10 years. And the plan is available at the link below in that slide. Go ahead, next slide, Carly. So Bridget had mentioned greenhouse gas emissions accounting and how it gets treated, really gets broken up into 3 different buckets of activity called Scope 1, Scope 2, and Scope 3. And she talked about like what we're required to account for. Just know that all of our emissions get translated into a common unit of measurement called a carbon dioxide equivalent, and that they're reported by scope or category. And they are available on the public reporting platform that Bridget mentioned and I linked in the chat. Next slide. There we go. So, you already know the story. It's been in the press. We've talked about it before, but we reduced emissions from 2008 to 2020, 51%. And that's, as Bridget just covered, a pretty notable accomplishment relative to our peer institutions and other signatories in Second Nature's database. Next slide. And I want to talk a little bit about the composition of emissions, because I think that matters a lot and will be helpful and instructive. Jeff asked what the big drop is in 2012, weather related, actually. So we had one of the warmest winters in Minnesota history, followed by one of the coldest, top 10 coldest, top 10 warmest, followed by top 10 coldest. Also simultaneous to that, we were moving some of our steam generation from coal to natural gas. And so those 2 things combined really precipitated a big decrease. It's a good question. Good eye, good catch. So emissions wise, where we started our planning activity in 2008, most of our greenhouse gas emissions were locked up in the electricity we are purchasing from Xcel. Over half of our emissions as a campus were coming from that electricity that we bought. And a third were coming from the fossil fuels we use to generate steam on campus. That's that category called stationary combustion. So when you think about the orange wedge, that's Xcel. When you think about the stationary combustion, that's all of our steam plants and our on-campus boilers that burn natural gas or other fossil fuels. And then the next biggest category was air travel. And then commuting was 5%. And then there's some small pieces around the university's fleet and fugitive emissions. Fugitive emissions are everything, all Scope 1 emissions, and they're generally associated with things like refrigerants leaking to the atmosphere, fertilizer applications on the campus farms and grounds, animals that we have on campus. We account for all the animals we have on campus and all their contributions to climate change. So that's what we mean by fugitive emissions. It's sort of a very large catch-all category of smaller emission sources that are of that nature. Next slide. And what has changed as we've reduced emissions 51% is we've really shifted what the pie looks like. So the pie has gotten smaller and the composition of the pieces of the pie have shifted dramatically as a result. So whereas purchased electricity used to be 50% of our footprint, it's now 15%. And now stationary combustion, the fossil fuels we burn in our on-campus plants, are a bigger share. I should point out that the carbon emissions that we had from stationary combustion in 2008 are almost exactly the same in 2021, 2020, while campus has grown about 4 million square feet. So it's not that we're inefficient, we're actually incredibly efficient. It's just that we've shrunk that electricity pie so much so quickly that now stationary combustion has taken on a much bigger emphasis. We're actually in the process right now of exploring other ways to get that last 15% taken care of. So maybe by the time you all engage in some climate action planning work, we will have some answers for what that looks like, but that's still a little bit TBD. And then the other big categories that you see there are air travel has grown since the 2008 inventory as a percentage of the pie. It hasn't grown a ton in terms of total or actual emissions, just as a percentage of the share. And then commuting is also growing. And that's actually has seen some growth in the commuting emissions. And we think that's largely due to our sophistication in calculating those emissions, not because commuting as a behavior is growing tremendously. We've grown the population some, but not that much to account for that big of an increase.